Now the next concentration term which we have to discuss is normality. But before starting normality, you should be very clear with a term that is equivalent weight and gram equivalent. So I'm starting now with equivalent weight. What actually is equivalent weight for a given element in a particular compound? So there are many definitions of equivalent weight. According to one definition, it is that weight of an element, equivalent weight is that weight of an element which can react with or displace 1 gram of hydrogen, 1 gram of hydrogen, 8 gram of oxygen, 35.5 gram of chlorine and 108 gram of silver. It is that weight of element which will react or displace 1 gram of hydrogen, 8 gram of oxygen, 35.5 gram of chlorine or 108 gram of silver. Just for example, if I want to find the equivalent weight of sulfur in SO2, so what we can say that 32 gram of sulfur has combined with 32 gram of oxygen in SO2, or to make you understand we can write it like this: S plus O2 will give you SO2. According to stoichiometry, what we can say that 1 mole of sulfur will combine with 1 mole of oxygen, and weight of 1 mole of sulfur is what? It is 32 gram, and weight of 1 mole of oxygen is what? It is also 32 gram. So with 32 gram of oxygen, weight of sulfur that is reacting is what? 32 gram. So if the weight of oxygen is 8 gram, with 8 gram of oxygen, how much weight of sulfur will react? So we can simply say that if with 32 gram of oxygen, 32 gram of sulfur is reacting, so with 8 gram of oxygen, the weight of sulfur that will react will be what? That will be 8 gram. And this 8 gram is what? This 8 gram is the equivalent weight of sulfur in SO2. Similarly, let's try to understand another example. Let us suppose we have to find the equivalent weight of sulfur in SO3, equivalent weight of sulfur in SO3. So again we can write the reaction: S plus 3 by 2 O2 will give you SO3. Have taken a balanced chemical equation, and as per this stoichiometry we can say that 1 mole of sulfur will combine with 3 by 2 mole of oxygen. 1 mole of sulfur will combine with 3 by 2 mole of oxygen, and this we can say on the basis of stoichiometry. Now 1 mole of sulfur means what will be the weight of 1 mole of sulfur? So it is again 32 gram. And what will be weight of 3 by 2 mole of oxygen? So we know 1 mole of O2 is 32 gram. So 3 by 2 will be how much? 3 by 2 moles will be 3 by 2 into 32, that is 48 grams. So we can say that 48 gram of O2 is combining with 32 gram of sulfur. Now our target is what? We have to find the equivalent weight of sulfur. And what is the definition of equivalent weight? So it is that weight of sulfur which will react with 8 gram of oxygen. So with 48 gram of oxygen, 32 gram of sulfur is reacting. So with 1 gram of oxygen, 1 gram of O2, what weight of sulfur will react? So that will be 32 upon 48 gram of sulfur will react. So with 8 gram of O2, how much weight of sulfur will react? So it will be 32 upon 48 into 8. So on solving this you'll get it is 32 upon 6 gram. So this 32 upon 6 gram is what? It is the equivalent weight of sulfur in SO3. This is equivalent weight of sulfur in SO3. So this is one definition of equivalent weight. There is another definition of equivalent weight, that is, it is that weight of substance which reacts with 1 mole of electron. Equivalent weight, another definition is, it is that weight of substance which react with 1 mole of electron. You can write it. It is that weight of substance. It is that weight of substance which reacts with 1 mole of electrons. Just a for example, I'm having Ag plus silver ion. So silver ion will react with 1 mole of electron to give you silver. So in this case what will be the equivalent weight of sulfur? So what weight of sulfur is reacting with 1 mole of electron? So from not sulfur, what weight of silver will react with 1 mole of electron? So from stoichiometry we can say that 1 mole of electron will combine with 1 mole of silver, and weight of 1 mole of silver is what? It is 108 gram. So this 108 gram is what? It is the equivalent weight of silver. So let's take one more example. If I'm having Cl minus will give half Cl2 plus electron. So 1 mole of Cl minus is giving you 1 mole of electron, and what's the weight of 1 mole of Cl minus? That is 35.5 gram. So this 35.5 gram will be the equivalent weight of this Cl minus. Let's take another example. Suppose I'm having Ca plus 2. So Ca plus 2 plus 2 electron will give you calcium. So 1 mole of calcium plus 2 ion, 1 mole of Ca plus 2 is combining with how many moles of electron? Is combining with 2 moles of electron. So with 1 mole of electron, how much calcium will react? So with 1 mole of electron, moles of calcium that will react will be half. So the weight of this half mole of calcium, that will be what? That will be its equivalent weight. So this can be written as 1 by 2 into molar mass of calcium, right? So in this way we can find the equivalent weight. Means equivalent weight of calcium in this case will be what? Equivalent weight will be molar mass of calcium, that is 40 divided by 2, which is 20. Suppose if I'm having Al plus 3, so Al plus 3 will gain 3 electron to get converted to aluminium. Now again from stoichiometry we can say that 1 mole of aluminium will combine with 3 mole of electron. So with 1 mole of electron, whatever weight of aluminum will react, that will be what? That will be its equivalent weight. So if with 3 moles of electron, 1 mole of aluminum is reacting, so with 1 mole of electron, how many moles of aluminum will react? That will be 1 by 3 mole. And weight will be what? Weight will be what we know. Weight is molar mass into number of moles. So that is molar mass of aluminium into 1 by 3, and this weight will be what? This weight will be our equivalent weight of calcium in this reaction. So ultimately we can write what? We can write equivalent weight is equal to molar mass. If you see, it is equivalent weight is equal to molar mass upon one quantity is coming in every case, and that quantity is known as N factor. So equivalent weight is equal to molar mass by N factor. Now if we know the molar mass and N factor, we can find the equivalent weight of any species. Is this clear? Now what actually N factor is? One definition, it's clear that N factor is the number of moles of electrons that is transferred. Like in this case, 3 moles of electron was transferred, so N factor was 3. In the previous case, in this case, 2 moles of electron was transferred, so N factor was 2. Again in the previous case, 1 mole of electron was transferred, so equivalent weight was, in this case it was 108 divided by 1, which is the N factor. So N factor is the moles of electrons transferred. So N factor is what? It is moles of electron transferred per mole of the reacting species, per mole of the reacting species. Now we can also define N factor for different species, like if I'm having acids. So for acids, N factor is equal to their basicity. For acids, N factor is their basicity. Now what is basicity? So basicity is number of replaceable hydrogen ion. Basicity is number of replaceable H plus ion. Just for example, if I'm talking about HCl, so in HCl only one replaceable H plus ion is there, so its N factor is 1. If I'm talking about H2SO4, N factor is what? It is 2, because it is having 2 replaceable hydrogen ion. The structure of H2SO4 is this. These 2 hydrogen, they are replaceable hydrogen. Which all hydrogen are replaceable? We can say the acidic hydrogen are the replaceable hydrogen ions. And which all are acidic? So the one which is connected with high electronegative element, they are generally considered as acidic, because if those hydrogens are removed, the negative charge will come on more electronegative atom, and negative charge on more electronegative atom, that is stable. So the conjugate base which is formed, that is stable. So this hydrogen or the particular hydrogen will have a tendency to migrate. So that hydrogen will be replaceable hydrogen ion. If I'm having H3PO4, so the structure of H3PO4 is something like this: P double bond O, OH, OH and OH. Now in this you can see that there are 3 replaceable hydrogen ion, so N factor for H3PO4 will be 3. If I'm talking about H3PO3, in case of H3PO3, what is N factor? So if we'll see the structure of H3PO3, it is like this: P, OH, P, OH and H. In this case we are having 2 replaceable hydrogen ion, because only 2 hydrogen are connected with oxygen, which is high electronegative. So in this case N factor for this will be what? That will be 2. If I'm having H3PO2, in case of H3PO2, again let's try to understand the structure. Structure is P double bond O, OH, H and H. In this only one hydrogen is replaceable hydrogen, so in this case N factor is 1. If I'm having H3BO3, in this case the N factor is 1. In this case the N factor is 1. The structure of H3BO3 is like this. Now all the acids which we have discussed above, that is Arrhenius acid, except H3BO3. H3BO3 is what? It is a Lewis acid. Now what's the difference between Arrhenius acid and Lewis acid? So Arrhenius acids are those acids which on addition to water will produce H plus ion, but Lewis acid are those species which have a tendency to accept a pair of electron. Now if 3 hydrogen are attached to oxygen, why its N factor is 1? Why all 3 hydrogens are not replaceable? So in this case what happens, if H3PO3 is added to water, it forms this compound POH4 minus. And what we can observe, that H3PO3 has accepted a pair of electron from water molecule, so that is why we say the N factor for H3PO3 is 1. Is this point clear? So this point is important, that N factor for H3PO3 is 1, and these 3 are also important. And H3PO4 N factor 3, H3PO3 N factor 2 and H3PO2 N factor is equal to 1. So these are for acids. Second is base. For bases, what is N factor? For bases, N factor is their acidity. Now what is acidity? So acidity is replaceable OH minus ion. Number of replaceable OH minus ion is known as acidity. Let's say for NaOH it will be equal to 1. For CaOH whole twice it will be equal to 2. For MgOH whole twice it will be equal to what? It will be equal to 2. So whatever is the number of replaceable OH minus ion, that will be equal to the N factor for bases. Next is for salts. For salts, N factor is the charge on either cation or anion. N factor is charge on cation or anion. Anyone you have to consider, either cation or anion. Just say for example, if I'm having NaCl, so NaCl is what? Na plus and Cl minus. So either you check the positive charge or you check the negative charge, which is what? Which is 1. So that is why N factor for NaCl is 1. If I'm having CaCl2, in this case it is Ca plus 2, or we are having 2Cl minus, positive charge is plus 2, and chlorine has one negative charge, but we are having 2 chlorine, so again total negative charge will be equal to 2. So N factor in this case is 2. Yeah, we can consider either positive charge or negative charge. As it is a neutral salt, ultimately positive and negative charges will be same. Suppose if I'm having Na3PO4, so in this case N factor is what? Let's check the ions. It is 3 Na plus and PO4 3 minus. So N factor in this case is equal to 3. If I'm having MgSO4, what is N factor? So MgSO4 is what? Mg plus 2 and SO4 2 minus. So N factor in this case is equal to 2. Suppose if I'm having Al 2SO4 whole thrice, aluminum sulfate, Al2SO4 whole thrice. In this case, what will be N factor? So again take now 2Al plus 3 plus, or sorry, 2Al plus 3, or anionic part is what? It is 3SO4 2 negative. So total positive or total negative charge is what? It is 6. One aluminum is having 3 positive charge, so 2 aluminum will have 6 positive charge. So total positive charge is 6. Or negative charge if you are considered, so 1 sulfate ion is having 2 negative charge, so 3 sulfate ion will have 6 negative charge. So for salts, N factor is equal to the charge on cation or the charge on anion, or we can say total charge on cation or anion. It's also clear, N factor for salts. Fourth is for redox reaction. Fourth is for redox reaction. So for redox reaction, N factor is moles of electrons transferred. Moles of electron transferred. First expression which you have written for N factor, moles of electrons transferred per mole of reactant, per mole of reactant. Just say for example, if I'm having MnO4 minus in acidic medium, so it is converted to Mn plus 2. So how many moles of electrons are transferred? So moles of electrons transferred, that will be equal to what? That is equal to total change in oxidation state. Total change in oxidation state means in this case oxidation state of manganese is what? It is plus 7. In this case oxidation state of manganese is what? Plus 2. So change is how much? Change is 5. So N factor for this is equal to 5. Suppose if MnO4 minus is changed to MnO2, so what's the N factor? So first you have to find the oxidation state. So over here oxidation state is plus 4 for manganese, and it is plus 7. Change is what? 3. So N factor is 3. MnO4 minus is converted to MnO2 in neutral medium. It is converted to Mn plus 2 in acidic medium. And one more is the possibility, it is MnO4 2 minus. This is in basic medium. So in basic medium, change in oxidation state is how much? Over here manganese has oxidation state plus 6. So 7 to 6 change is what? 1. So N factor will be 1 in basic medium. Let's do one more question. Suppose if I'm having Cr2O7 2 minus is converted to Cr plus 3. Now in this case each chromium has oxidation state plus 6, and change is what? Change is 3 for 1 chromium atom. We are having 2 chromium atom. You can have to be very clear in this case that change in oxidation state for 1 chromium is equal to 3. So change in oxidation state for 2 chromium, that will be what? That will be 6. So N factor in this case, that is equal to 6. Let's take one more example. Suppose I2 is changed to I minus. What is change in oxidation state, or what is N factor? So over here oxidation state is 0, over here oxidation state is -1. How much is the change? So change is 1. For how many atoms? So for 1 iodine atom change is 1. So for 2 iodine atom change will be what? Change will be equal to 2. But if I am having this reaction, I minus is converted to I2. So change is what? -1 to 0. So change is only 1 for one iodine atom, and on the reactant side we are having only one iodine. So in this case N factor will be equal to 1. So for redox reaction, N factor is what? It is the moles of electrons transferred per mole of reactant. And if only one atom is there, that will be change in oxidation state, and if more than one atom is there, so in that case you have to multiply by the number of atoms which is present. Understood? So let's do one more question on this concept only. Suppose if I'm having C2O4 2 minus and is converted to CO2, what will be N factor in this case? So again, oxidation state of carbon in this case will be what? +3. In this case oxidation state of carbon is what? +4. Change in oxidation state will be 1 for one carbon atom. So for 2 carbon atom, change in oxidation state will be equal to 2. So N factor for carbon in this case is equal to 2. So N factor also depends on the number of atoms which is present in the reacting species. Ultimately it is what? Ultimately it is the moles of electrons transferred per mole of the reacting species. So I hope now you are very clear with the concept of gram equivalent. Sorry, you are very clear with the concept of equivalent weight. Now let's move to the concept of gram equivalent. Achha, let's write it finally, that what we have studied. We have studied that equivalent weight is equal to molecular weight divided by N factor. This formula is very important. This we have to remember, that equivalent weight is equal to molecular weight divided by N factor. Now let's come to the concept of gram equivalent. Let's come to the concept of gram equivalent. I hope you have studied about moles, right? So gram equivalent is again a similar term as that of mole. Numerically, gram equivalent is equal to given weight in grams divided by equivalent weight. Gram equivalent is what? It is given weight upon equivalent weight. Means with the help of this relation, what we will find? We'll be able to find that how many gram equivalents are present, and the gram equivalents will give me what? The gram equivalent will give me the moles of electrons which is either gained or lost by that much amount of that species. Suppose I'm getting that gram equivalent is equal to 5. So what does that mean? It means that 5 moles of electron is required or is transferred by that much amount of the given species. So gram equivalent is telling us about the moles of electron that is required for the reaction. Is this clear? So we can also write this expression as given weight upon equivalent weight can be written as molecular weight upon N factor. So this I can write as multiplied by N factor. And this term, if you remember, given weight upon molecular weight, given weight upon molecular weight, that is equal to what? That is equal to number of moles. So moles into N factor, moles into N factor will give me what? Will give me gram equivalent, or we can say number of gram equivalent is equal to moles into N factor. N factor is what? N factor is what? Moles of electrons required. And if I'm having suppose 2 moles, so 2 moles into moles of electrons required, ultimately is giving you what? Ultimately it is giving you the total moles of electron which is required for that particular given weight of species. So this formula is also important, that number of gram equivalent is equal to moles into N factor. And this formula is also important, that gram equivalent is equal to given weight upon equivalent weight. Now if you are clear with these terms, I'm not giving you questions on this. I'm directly moving to the term normality. I hope you have solved all these questions in law of equivalence, which you might have studied in stoichiometry. So next, let's move to normality. Now, normality is a concentration term, same as that of molarity. Only difference is that in case of molarity, we were using moles of the species or moles of the solute. But in case of normality, in place of mole, we will be using gram equivalent of the solute. So, normality is what? Normality is, it is the number of gram equivalent. It is the number of gram equivalent. It is the number of gram equivalent of solute present in number of gram equivalent of solute present in 1 liter of solution. Present in 1 liter of solution. Mathematically, we can write normality is equal to number of gram equivalent of solute, number of gram equivalent of solute divided by volume of solution, volume of solution in liters. Clear? Normality is number of gram equivalent of solute divided by volume of solution in liters. And we have seen above that number of gram equivalent is what? It is moles into n factor. So we can also write normality is equal to moles into n factor, moles into n factor divided by volume of solution, volume of solution in liters. And moles upon volume of solution in liter, if you remember, it is what? It is molarity. Moles upon volume of solution is what? It is molarity. So normality is what? Normality is molarity into n factor. This is another relation between normality and molarity, that normality is equal to molarity into n factor. So one more point, that in normality we are using volume of solution, and if volume is used, it has to be temperature dependent or independent. It has to be temperature dependent. So normality is what? It is a temperature dependent. It is a temperature dependent concentration. Now this point has to be studied very carefully, because a number of times they have asked question on temperature dependent and temperature independent concentration terms. So whichever is involving volume, that is temperature dependent, and if it is not involving volume, if it is involving mass, then it is temperature independent. So molarity is what? Temperature dependent. Molality is what? Temperature independent. Mole fraction is what? Temperature independent. And normality is what? It is temperature dependent concentration term. Clear? Now let's do some question on normality. Question: calculate the normality of 2m H2SO4 solution. Calculate the normality of 2m H2SO4 solution. So it's very simple question. Directly you can use formula that normality is what? Normality is molarity into n factor. And what is n factor for H2SO4? N factor for H2SO4 is acid, and for acid n factor is their basicity. Basicity is what? Replaceable hydrogen ion. And how many replaceable hydrogen ion? 2. So n factor for this is equal to 2. So ultimately normality will be what? Molarity is 2 into n factor is what? 2. So normality is equal to 4n. Clear? So let's do another question. Calculate the normality of H2SO4 solution. Calculate the normality of H2SO4 solution which contains 98 gram of H2SO4 in 5 liter of solution. Calculate the normality of H2SO4 solution which contains 98 gram of H2SO4 in 5 liter of solution. So what's the formula? Again, these are directly formula based question, that normality is number of gram equivalent of H2SO4 divided by volume of solution in liters, and normality will be equal to what? Number of gram equivalent. Now how will you find gram equivalent? Weight is given, so we have seen one formula, that number of gram equivalent is weight divided by equivalent weight upon volume of solution in liters. Now weight is given, volume is given, what about equivalent weight? So we know equivalent weight is equal to what? Molar mass, molecular weight or molar mass divided by n factor. Now what's the molar mass of H2SO4? So molar mass of H2SO4 is 98 gram per mole. And what's the n factor for H2SO4? It is equal to 2. So equivalent weight of H2SO4 is 49 gram. So using this in the above equation, we'll get weight given is 98 divided by 49 upon 5. So it is 2 by 5, which is 0.4 n. So normality of this solution is 0.4 n. Understood? So if they have given weight, then also you can find the normality of the solution. So let's do one more question. Calculate the normality of a solution. Calculate the normality of a solution which contains 2 moles of H2SO4 in 5 liter solution. What will be normality of a solution which contains 2 moles of H2SO4 in 5 liter solution? Again, directly formula based question. Normality we have to find. Normality is what? Number of gram equivalent of solute divided by volume of solution in liters. And what will be number of gram equivalent? They have not given number of gram equivalent, but they have given what? They have given the number of moles. And from the number of moles, how can we find gram equivalent? So we have seen one relation, that number of gram equivalent is equal to moles into n factor. Moles into n factor will give you number of gram equivalent upon volume of solution in liter. That will give me what? That will give me normality. So moles is how much? 2. N factor for H2SO4 again 2. I hope it's clear. And factor for H2SO4 is acid, its basicity, which is 2, upon volume of solution is 5. So which is equal to 4 upon 5 n, or we can also write it as 0.8 n is the normality of this H2SO4 solution. So in this way we can calculate the normality of any given solution, and if normality is known, we can find the gram equivalent of a solution. Let's do one question on that concept again. Calculate the number of gram equivalent. Calculate the number of gram equivalent of H2SO4 present in, let us suppose, 100 ml of 0.2 n H2SO4 solution. So what we have to find? We have to find the number of gram equivalent. They have given normality and volume. So what we know, normality is equal to number of gram equivalent of solute divided by volume of solution in liters. In this they have given normality, they have given the volume of solution. What they're asking the number of gram equivalent of solid. So I hope this will be very clear, that number of gram equivalent will be equal to normality into volume of solution in liters. I'm using short form, and for normality V for volume of solution in liters. So normality is 0.2 into volume of solution is 100 milliliters, so which is 100 upon 1000 liters. So this will be equal to what? That will be equal to 0.02 gram equivalent. 0.02 gram equivalent. Achha, if I'm writing it as normality into volume in milliliter, in that case what we will get? So in that case we will not get number of gram equivalent, we will get number of milligram equivalent. Number of milligram equivalent. So if I'm using volume in milliliter, we'll get milligram equivalent. If I'm using volume in liters, we'll get gram equivalent. Clear? This concept is also clear. So let's do one more question. Calculate the weight of H2SO4 present in 100 ml of 0.1 N H2SO4 solution. Now what should be our approach? Understanding question will not help you. What you have to learn the approach which I am making, or what should be our approach while solving a problem, how we have to think when we are getting a problem like this. So first what we have to find weight of H2SO4. What they have given? Normality and volume. So till now whatever we have done, from that it will be clear that if normality and volume is given, we can find number of gram equivalent. If normality and volume is given, with the help of that we can find what? We can find gram equivalent, right? And if I'm able to find gram equivalent, that gram equivalent can be converted to what? That gram equivalent can be converted to weight. You are getting my point? How will we get gram equivalent from normality and volume? So if I'm multiplying them, we'll get gram equivalent, and if gram equivalent is multiplied by equivalent weight, remember the formula, that gram equivalent is equal to given weight divided by equivalent weight. So if you multiply gram equivalent and equivalent weight, what will get? We'll get the weight of H2SO4. So let's do this question fast. So number of gram equivalent will be equal to normality into volume in liters. Normality is how much? 0.1. Volume is how much? 0.1. That is equal to 0.01 is gram equivalent, and gram equivalent is equal to weight upon equivalent weight. So weight will be equal to number of gram equivalent into equivalent weight. Number of gram equivalent is 0.01 into equivalent weight of H2SO4. Now equivalent weight is what? It is molecular weight upon N factor. Molecular weight is 98 upon N factor is 2. So it is 0.01 into 49, which will be equal to what? 0.49 grams of H2SO4 is present in the solution. So in this way we can solve the questions which are involving normality as a concentration term. Clear? So this much was in normality. After this, the next concentration terms which you have to understand, that is percentage weight by weight, percentage weight by volume, and percentage volume by volume. These three concentration terms we have to understand. Percentage weight by weight is what? So whichever part is in numerator, that represents solute, and whichever is in denominator, that represents solution. Numerator is representing solute, and denominator is representing solution. Like first is percentage weight by weight. So both are weight, so it will be what? It will be weight, numerator solute, so weight of solute, upon denominator again it is weight by weight, it is again weight, so it is weight of solution. And if I'm calculating percentage, so we have to multiply this by 100. So weight of solute by weight of solution into 100, that will give me percentage weight by weight. Just say suppose if I'm saying that if I'm having 30% H2SO4 solution or 30% weight by weight H2SO4 solution, so what does it mean? So it means 30 gram of H2SO4. Whenever I'm talking about percentage, so it is always in 100. So 30 gram of H2SO4 is present in 100 gram. Why we are taking gram? Because it is weight by weight. So 100 gram of solution. Clear? 30 gram of H2SO4 is present in 100 gram of solution. Second is percentage weight by volume. So what we will write? Numerator is for solute. So in numerator we have W. W stands for weight. So it is weight of solute divided by, in denominator we have V. V stands for volume and it is for solution. So it is volume of solution into 100. So if I'm having 30% weight by volume H2SO4 solution, now what does it mean? So it means that 30 gram of H2SO4 is present in 100 ml of solution. 30 gram of H2SO4 is present in 100 ml of solution. Numerator is always for solute, denominator is for solvent. Sorry, denominator is for solution. So percentage weight by volume means weight of solute by volume of solution into 100. If nothing is mentioned in the question, they have given percentage and nothing is mentioned, it means it is percentage weight by volume. Third is percentage volume by volume. So now you can tell me it is volume of solute divided by volume of solution into 100, which means that if I'm having 30% volume by volume H2SO4 solution, it means what? It means 30 ml of H2SO4, 30 ml of H2SO4 is present in 100 ml of solution. 30 ml of H2SO4 is present in 100 ml of solution. So these all are percentage concentration term. Now first one, percentage weight by weight. It will be temperature dependent or independent. So both numerator and denominator, they are what? They are weight, and weight is temperature independent. So this concentration term is temperature independent. Percentage weight by weight is temperature independent. Percentage weight by volume, volume term is coming, volume is temperature dependent. So this concentration term is temperature dependent. And third one, volume is coming in this. One doubt you might have in third, that both are having volume terms and both are temperature dependent, so both should cancel each other. But the temperature dependency of solute and solution, they may be different, and if temperature dependency is different, they will have some temperature dependency, they will not cancel each other. So this is again what? This is again temperature dependent concentration term. So percentage weight by weight, temperature independent. Percentage weight by volume, temperature dependent. And percentage volume by volume, that is also temperature dependent concentration term. So these are three percentage concentration term. And one important point in this is that if nothing is mentioned, it is percentage weight by volume concentration term which is given in the question. Suppose in the question they are saying that find the molarity of 30% H2SO4 solution. So let's do this question. Find the molarity of 30% H2SO4 solution. How will you approach in this question? So first, what we have to find? Molarity. What's the formula for molarity? Moles of solute divided by volume of solution in liters. So these two terms we have to find, then only we'll be able to calculate molarity of the solution. Now what they have given? They have given 30% H2SO4 solution. 30% H2SO4 solution mean 30% H2SO4 solution. What does it mean? Nothing is mentioned. Means it is what? It is weight by volume, which means 30 gram of H2SO4 is present in 100 ml of solution. In all the concentration terms we are using liter. In molarity, volume was in liter. Normality, volume was in liter. But in percentage we are using milliliter as volume, right? So what we know the weight of H2SO4, and what we know the volume of solution. So volume of solution we knew that it is 100 ml. We have to find moles of solute. Now from weight of H2SO4 can we find moles? Yes. How can we find moles? So number of moles is equal to given weight divided by molar mass. So this is equal to 30 divided by 98, and this is what? This is moles of H2SO4. Volume of solution is 100 ml. So now we can put the value and get the molarity. So molarity is 30 upon 98 divided by 100 upon 1000, so which is 300 upon 98. This will be the molarity of this 30% H2SO4 solution. So in this way we can calculate the molarity if they have given percentage weight by volume, or we can calculate percentage weight by volume if they have given molarity of the solution.